All right, thank you all for coming. I really like YAP-CNA, and it felt like I haven't been here in like at least a year. So I get to talk about this thing that I did, which I mainly like because it gives me a chance to complain about things that I tried to solve. So if I'm way too loud at some point, just let me know. All right, so I wrote this thing called Util. I'd like to tell you about it. But first I have to kind of present myself a little bit because not everyone knows who I am. This is me. My name is Sawyer, or Sawyer X. I work at Booking.com. If you are interested, we are in a high interest for other people to join us and work with us. If you would like to move to Amsterdam, if you would like to work with really, really awesome people, I'm there too, I guess. But other awesome people, like Gonzalo, Vicente over here, then please come see me after. I write Perl for fun, sometimes profit. I am the maintainer of the Dancer2 web framework. I summarize the Perl 5 core development mailing list. I am generally a project leader in various projects, and I write code once in a while. I'm the current Perl 5 pumpkin, which is kind of like the project manager for the Perl 5 language, which is, for me, it's very exciting because I get to work with a lot of really brilliant people. I'm very bad at writing bio. I hate it. I'm terrible at writing lists and daffodil. All right. So a little bit about Util. It started from this small email by Jarkko Hietaniemi, who is one of the older generation Perl 5 developers. By Wikipedia, he is actually in charge of like a quarter of the Perl 5 code, so this is like a serious person. And he wrote a small email saying, hey, I have a random idea for a very, very, very small micro-optimization. This is from his email. It says, if you do a ref on something, A here might be confusing because Perl actually defines an A sometimes. But if you take something, let's say foo or A, and you call ref on it and then check if it equals array, what actually happens is that it will compile the array into a string and they will do an EQ against a constant, which is kind of silly because what you're actually trying to do is simply verify whether it's a certain type. And we know this, but instead we're creating a constant and then we're doing this. It's kind of silly. Maybe we could optimize this. So I thought, all right, well, let me take a look at this. So let's take a look at this problem. If we have my foo and it is an array ref, and then we call print foo, if it's equal as array, yes or no, what will this give us? Yes, very good. Yes. Now, what if I do this? Yes or no? In case you haven't seen the slide after. No, and the reason is actually simple. We misspelled array there. Whoops, different constant. Okay, so we have to put this here, and now it's good. But what about now? No, because this is now a hash ref. It's kind of hard to spot. So no. But what if we did this? Yes. Why would I do that? Well, I wouldn't, but people. So the thing with this, I mean, before I explain how we solve this, the actual problem with ref, and what I try to explain here is that ref is used for two specific things and it fails at both. The first one is that it is used to check whether a variable is of a certain type. Perl has several types, scalar, array, hash, and it checks whether it's a reference to one of those, except if it's blessed, because then you can't do that. But then you want to check sometimes if something is blessed into a certain package, except if it's not, if it's blessed into a different package or it's not blessed, which is really, it's used for two things and doesn't do either of them correctly. So there is a way to solve this in Perl. The first one is to use, the first thing we got to do is use ref type. So we'll take this thing, which we have blessed an array ref into a class call package, and we call ref type on this. This will give us array, again, as a string. So now we can do this same thing. Even if it's blessed, you can see that it says that this is an array ref. Fantastic. Now, what if we take a string instead of a ref, and we check ref type? So ref will give us, pardon me, some stuff. There we go. So if we call ref on this, okay, that's good. But if we call ref type on this, we actually get an initialized value because ref type for a design feature at the beginning or a design decision at the beginning actually returns undef. Not empty, because the ref will return empty, but ref type will return undef, which means that you now get a warning because you're trying to compare undef to something. And then it says, well, I don't think it can compare. Woo. Okay, I don't think it can compare. No, this is not the right thing. Technical difficulties. Why is it like this? Let's take it out, let's put it back in. How long does it take it to cycle? This long. Okay. So it actually returns undef, and then you have a warning. And some people actually use fatal warnings, and then this even dies, like the entire process closes because there was a warning somewhere. So this is a problem. So what we actually need to do is take the ref type, but then we have to, check if it's a ref. So whatever we get this from, we now have to check, is it a ref? If it's a ref, then I can run ref type. Because if it's not a ref, then if I run ref type, then I get an uninitialized. So this is the way you solve it. Okay, so I wrote this other thing called is array ref, which I think would be kind of nicer, no mistakes. You can implement it in pure Perl this way, but that would be too easy. So I thought about doing it in a different way. There would be another variable for another function for is hash ref. There will be another function for is scalar ref. What else do we have? Code refs, and we have, this is a code ref. What else? We have regex ref, right? We have glob ref. Format ref, there you go. There's IO ref. There is one more that I did not include here that I did not even think about at first. Ref. That exists. Okay. So I wrote all of these, and I put them inside a module called Util. The capitalization is not really correct here. It is written in XS, and I'd like to explain how I wrote this. XS, in a way, feels kind of like this. It is very, very, very powerful, and I was looking for stuff like that, so I found this picture, and then I found this picture, which I really like. Eventually, I ended up with this one, which I love. But what actually XS does is give us a lot of power, and power is actually kind of scary, but at the same time, power is about simplicity. Perl has data types. I mean, take a look at an SV. Who here has heard the term SV? Okay, so an SV is basically the way the Perl relates to variables. It means scalar value, which is the data type for any scalar that exists. So we can take a scalar value and know that it is scalar. There is also ones for other variable types like arrays and hashes. So we got this, well, types, sort of. So if we take a look at this thing, this says SVT PVAV, which is short for a type of SV, a type of scalar, which actually represents an array. So that would be, right, an array. And we can use a macro called svtype to get the type of a variable and then check, is it an array? Hey, that's really nice. So we call svtype, we get a value, and we'll get a result. If it's a reference, we can also deref it by using svrv, which means deref a reference. Get the sv of this reference value. Give it a ref, we get that result, and we check that type. So this is a deref plus check whether it's an array. It's that simple. We can also check if it's a reference to begin with, so we don't try to dereference it by accident by using svrok. So is it okay to treat this as a reference? If it is okay to treat this as a reference, I would like you to deref it, and then I would like you to check if the type is of an array. It's that simple. We have just written an XS function. We will probably want to return success or fail, so we'll use XS return yes and XS return no to decide whether it was correct or not, and that would be yes or no. And you can see those here, and of course this is a wrapper just to define the function. The SV star at the beginning says we will return a scalar value, that will be our Boolean result, and the SV inside will say we will receive a scalar value. So we receive one parameter, we return a result. This is now an XS function. We finished writing an entire XS function that does it. It's not that complicated, right? All right. So the fun thing about though is that I wanted to do something a bit more interesting. We have a small subcommunity work that plays with the Perl 5 internals, P5P Club, and it's a very good opportunity for us to learn the core and to play with the core, and mainly for us to learn from other people around us who are very knowledgeable in that field. So I looked at this and I discussed with other people in the group and said, well, it's fast, but it's not really that fast. Like that optimization was so micro, I could barely find it. So how could I do this in a more powerful way, in a strong way, in a faster way? So I decided to play with custom ops because someone suggested it. So what custom ops are, they're basically a way for us to introduce operations into the tree of operations that Perl compiles from a piece of code that it reads. A lot of people think that Perl, because it's an interpreter based, it doesn't do compilation. It's just running. That's not true. It actually compiles all of the code into a tree of operations. And then it walks through that tree of operations. There's even a layer that optimizes those tree of operations to say, hey, I can let go of this operation and I can put both of these operations and do them as a single one, et cetera, et cetera. So custom ops allows you to add your own operations inside it, which is really mind-blowing because it plays with the compiler level stuff. And it was a lot of fun. And I want to share with you how I did this. So what we're going to do is write the entire implementation in ops, which means that we're going to play with the compiler level stuff. It is kind of scary at first, but it's not very long. We're going to walk through this. And the first thing that we have is to define an XOP, which is basically a struct that helps us describe the operation that we will create, which is useful for debugging. So we create a static XOP, we give it a name, and what we do now is we call two functions that set values in that XOP to describe the op that we will create, okay? We set the XOP entry set to isArrayRef XOP, and we set the XOP name to isArrayRef and the XOP description to ArrayRefCheck. I'm not very good with descriptions. If anyone would like to submit a patch that basically gives better naming to this, by all means. The best person to describe your project is not you, is the person who's using it. So once we've done this, it's fairly simple. Now we move on to register in Perl that we have our own custom operator. Okay? So we call custom op register. The ATHX that you see at the beginning is something you copy paste. It's basically to provide context to the current running Perl interpreter. If you don't know what that means, it's fine. The documentation shows you this. You can just put that back in. It will make things faster and correct. And we say that we have an op in isArrayRefPP. We don't have one yet. We'll have to create it. And the description for it is found in isArrayRef XOP. So far, so good. We created a description. We defined that we will have an op with that description and with the name, the place for one, but we haven't written it yet. So now we're going to have to also write it. Now, what we need to do now, before, you know what, I'll take this one back. It's a bit weird to explain this. What we would like to do is introduce a function that will effectively run a new op. In order to run that new op, we have to hook this into compile time of the program. And the way that we do this is that when Perl hits, we will create a function. When Perl hits that function, we will replace it in the tree with an op that we created for it, that implements it instead. It's really bizarre. But once you see the code, you'll understand what it actually does, I hope. And there's room for questions, I guess, right? So the first thing that we do is we create an anonymous function and we get the address for it, which is the CV there. It stands for code value. So if you create a sub and store it in an anonymous function, this is the same thing. This creates an anonymous function. Except we can even provide a name for it. What we want is to create a function and receive that address for the function. So we say, we're going to define refutil is ArrayRef. This is going to be a new function that we define. This is the full name for it. This is the implementation for it. I think this is for where it is defined. It is the where it is defined. And this is the signature for it, the prototype. Sorry, this is the prototype, just like if you would do, this is the equivalent of sub is ArrayRef and then in parentheses $, same thing. Except in this case, we just define one and got an address for it. And the reason we have this address is that we could find it and then replace it. So, okay, it's kind of crazy. The next thing that we do is we ask Perl to set a function that will be called as soon as this function is called. So if someone calls isArrayRef, we want to grab that and we want to run a function. It's called an CV, set call checker. It is a call checker, and we use set call checker for it. So we're going to say, for a CV that we have, we would like to set a call checker. So as soon as it's called, the checker function will be run. We can do whatever we want in the checker function, but we basically want a hook. This is the equivalent of a before hook, basically, if you're familiar with method modifiers. So before the CV function is run the thing that I have. So this is what we wanted to monitor, which will be implemented there. We will write it. And this is what you run before you call that function. Okay, so now we need to see how we created the op, we need to see how we created the access function, and the checker for them. So first, how we create the op. The op is actually very simple. It will be pretty much the same code that we wrote, because that's the check. The first thing that we have to do is actually call declare stack pointer, which means I would like to read arguments. I have arguments, and I would like to be able to access them. So in order to access them, we need a pointer to that stack, which is the @_ when you send stuff to functions, and we want to be able to access it. So the DSP says declare the stack pointer. Then what we're doing is saying pop something off a stack, which is the equivalent of shift @_. We want you to take something off the stack and give it put it in ref. This is the same code as before, except we used PL_SVS, PL_SVNO, which are global values in Perl to say true or false. It is the equivalent access return yes, access return no as values, except the access return yes is only in excess, and it actually returns the values. So in this case, we're going to set those values. Yes?
Is the indentation special in any way in any of this?
Yes, I'm using it as an indicator to put more stuff. There you go. Good question, because now I have, that was my path to press space. Right, so the thing is that we can't just exit out. What we need is to communicate back communicate back a result to whoever called this function. Now, when it's access, we can just say return yes, return no. That's simple. Access is is definitely easier. But in this case, because we're playing with a stack to say give me arguments and here are arguments back, we effectively need to take something from the stack and then put something on the stack back. Because what we took was the argument we received. What we put back is what we're returning, right? We're basically interacting with the person who called the function using this array style thing, which is basically our stack. We take stuff, we put stuff back, right? So the DSP says, we're going to do this thing. We're going to play with that. The pop says, give me the first item. The second one, the push, basically says, and put this item back for them to use, okay? Which will be the return value. And that's why we use PL_SVS and PL_SVNO instead of basically saying access return and access, all that stuff. Now, it is very important that we indicate to the interpreter that we succeeded in running this op, that this operation was actually successful. It is fairly complicated. I'll present it and then I'll take some time to explain it. We return normal. That's it. All right, that's it. So this is the entire implementation of an operator in Perl. That's not bad. Okay, so once we have the operator and we registered it, we now want to basically do a magic trick where we declare a function, then we declare a hook to be run before the function is run, and once that hook is run, we're going to take that function, throw it out, and put our special op instead, which is like the old switcheroo kind of thing. I don't know what that actually refers to originally, but it sounds cool, so I'm going to use it now. So we have isArrayRef, then we're saying when isArrayRef is called, call this thing, and then that thing will remove isArrayRef and we'll put our op instead. So let's take a look first at that access function. What I did originally was I wanted to know if I was able to replace that function successfully. So in order to make sure that I replaced that function successfully, I basically said, well, if you hit the original function, then I didn't replace it properly. So just die. Croak is available in access. You can use it. It is similar to Croak in pure Perl. Now, here's the thing. There is a situation in which Perl will effectively not replace the function, even though my code is correct. And the way that it does is if I get around the compilation phase for that function. And instead I call this function dynamically. Perl is a pretty crazy language in its abilities, and I mean that in a good way, and that allows Perl to actually also allow it to dynamically call a function, even though it has compile time definitions. And in that case, what happened is that I just started croaking, and that was kind of weird. And someone told me, well, you got around the compilation. So of course, you weren't able to run your compiled code on it. So eventually, I put this in a macro and then just put it back in with excess return yes, excess return no. But this was how I originally wrote it, to just make sure that I'm able to replace it. So okay, the next part will be this guts, which is basically, it will get called as soon as isArrayRef is called, and then it will replace the core of isArrayRef with the op that we created before. So we have this thing, we have this thing. What we want is another part that gets called and then just takes this out, puts this instead, and that's it. That was actually the longest part. It's this, that's it, and we're gonna go over it. So I'm getting close to the end, but we're gonna go over it. So it is another op. It is called I called it the check enter sub args for isArrayRef, because the way that it works is it's called a call checker. That's just the name of that that mechanism, and it receives an op that it's supposed to run and some variables. The first thing that I do is called check enter sub args proto, and I do have an explanation on what this does. It performs the fix-ups of the arguments part of an enter sub op tree based on a subroutine prototype. And this makes modification to the argument ops from supplying context up to inserting different ops and checking the number and syntactic types of arguments as directed by the prototype, which to me says, just put this in. And it was fairly simple. It's basically saying, I have an enter op, please check it and see if you need to change something. So once we've called this, what we need to do is crawl up the tree, because now we're playing with an actual compiled tree, right? So it read the program, it compiled the tree, and now we have this tree and we want to take something out of it and put something different inside it. And this is a print using -mo concise, which gives you the concise output of the op tree that Perl has. Now I've cut out a few things. That's why you don't see some of the numbers, because they're now relevant. But these are the relevant parts, and the order of execution for them is the numbering that you see on your left side. So the first thing that we have is a push mark. A push mark basically says we have a list of arguments. And the next one is foo, which is the, if we're thinking about ref, foo, isArrayRef to foo. Foo is the argument in for. The second part is isArrayRef. So what's actually happening is that it first creates a list and puts foo inside it. Then it will run isArrayRef on that with those arguments. That's how the compiler works, okay? And at the end, it's gonna exit and finish and call the intercept, which is the exit part of the sub. So we need to crawl down that path. We need to go into the list. We need to grab that foo. We need to grab the ArrayRef, et cetera, et cetera. We need to reach all the way into 5. So we take enter sub and we cast it, which means that we change the way that we can access it so we can use it the way we need to. It is the C on op, which cast to unary op, which means treat this as something that has an argument, okay? And then we call the first op there, which now allows us to access the push mark, because we are in line 6. I know I said it's the order. 6 will be the point of exit. That's why it goes back up. So 6 is also the first part. So now by looking at enter sub, treating it as a unary op, which means we treat it as something that has an argument, we can access the first element inside it. The first element inside it is push mark, which will represent the arguments. It's a list. Now, because it's a list and we want to access something inside it, we need to treat it as a list that has arguments. The same thing as the cast unary op. So we're going to do something a bit more complicated, which is cast as a list op, which means it's a thing that has multiple arguments, which it does. It's a list. Okay. Now we can go into the first one there, which will be foo. So we're going to get to that. Okay, we need to move forward again. Just say, get the sibling, because it's a list. Just keep going. So the sibling will be is_arrayref. So now we hit is_arrayref. We found the actual op in the tree. Imagine a tree of operations. And we want to play with that and splice it. So we were now walking that tree and we found the single op that we want. Now that single op represents the excess version of it, which in the original implementation would just croak if you actually try to run it. In the new implementation, it still runs the same thing, but we noticed it wasn't fast enough. And now we want to yank out that excess implementation and go, forget the excess version. We wrote an op. Put that one in instead. So let's do that. First of all, we put it in a variable so we can use it. We say that after this, there are no other arguments because we're going to cut this, and our arguments will be the last that you get. We create a new op using new unary op, which means we are creating a new op that has one argument. Op null means we're starting at a null. It has nothing inside it at first. Then we set that type to op custom. And we set the address of it, which means where it's going to go for the code, to the op that we created. So we effectively changed, well, we haven't changed yet, I'm sorry. We effectively created a new op and set it to our address, the implementation. And now we just got to do the replacement, okay? Return new op. That's it. So by cutting the sibling, and by returning a new op from the call checker, we effectively are replacing what the function we're checking, which is the access function. It's a lot to take in at first, but it's very little code, and it's not really magical. It's fairly simple from the perspective of the actual work that needs to be done. It requires a lot of understanding. I can tell you that I had about maybe 12% understanding of this when we started, and we walked through this entire thing, and it took us about 2 hours, but it was a lot of fun, and now I understand it a bit better. There's still things here I don't understand, and that's fine, and I'm still learning them, but I think it really displays that you can do quite a few things relatively easily from a technical perspective, even if we just don't know all the background for it yet. So, okay, it's very powerful. That's great. I really enjoyed it. So now that we did a custom op, I looked into this. Custom op were actually introduced in 5.8, so they go way back. However, this mechanism that we use, the SV set call checker, that allows us to have like a before hook for a function, that allows us to replace that function and all that cool stuff, they were actually, along with XOP entry, only introduced in 2010. And we have this legacy of compatibility as much as we can. With great power comes something. So I looked into this and I thought, well, okay, well, what do we do if we're not in 2010? Am I going to say, well, this just doesn't work, which is also fine. Well, I can do this trick in C. It's fairly simple. XS is basically C. It's just some sugar on top of it to make it easier. And this is just a definition in the compiler that says, hey, look, if you can find a function called CV set call checker, and you can find a macro called XOP entry set that I'm using, then set a flag that I'm using custom ops. And if you can't, set it that I don't have it. And then the rest of the code basically says, if def use custom op, everything. Else, the XS code that we started with. When it will get compiled, the compiler is going to run these lines and will say, well, okay, wait, I don't have these functions here. I guess the Perl version they have is too old. So it's going to set use custom ops 0. Then later in the code it checks, do I have custom ops? It's going to say, nope, you don't. So it's going to jump into the else clause, and the else clause says, well, you remember that small snippet of XS with XS return yes, XS return no? Use that instead. and it will use that instead, and it will compile just fine. You will just get the XS version, which is just a little bit faster. So, no harm, no foul. You'll still need a compiler though, right? All right, this is the XS version that it's going to use, right? This is just in an else clause. To reduce duplication, I actually rewrote some of this with a bunch of macros just so it wouldn't be a lot of copy-paste stuff, but this is effectively the implementation. So that's actually fairly simplistic. Like, I thought this would be the complicated part, but that was like just an if, which is not that bad. So now speed, okay, because we started with speed and we ended up with ref is stupid, but we started with speed, so what would be the difference? And when I wrote the XS version, it wasn't that much faster. And I complained, and they were like, well, if you write an op, it might be faster. It's like, all right, how fast is it? Well, this is the XS version. The part that you care about is not the iterations, not the outliers. What you actually care about is the number 3.0093, which represents how fast it took for the test to run. Okay, this is using dumbbench, which despite its name, it is very smart compared to benchmark.pm. If you ever want to do benchmarks, please take a look at dumbbench. It's one word. Okay, it was written by Stefan Mueller, a core developer, knows a little bit about this, and I really, 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 really recommend it. So I ran the XS version. That's it. Then I ran the pure Perl version, which ran at twice as long. If you take a look at the ref type, are these older slides? Pardon me. Okay. So if you take a look at this, you'll notice the ref type runs at 9 seconds. So the ref type is actually the proper implementation of this. So that's not that bad. Okay. So it is, I do apologize. I think these are the wrong labels for it. I believe this is the op. This is the op. The XS version actually refers to the op. This is when you call ref, and this is when you call ref type, right? Is that clearer? I apologize for the confusion. So what you see here is that if you actually use, I'll remove this comment for a second. If you actually use ref type, which is the correct way, which is ref and ref type, because you can't just call ref type, it might be it might not be a ref, and then it's undev, and then it's a warning, and then maybe it's fatal, and then everything dies, and then you start crying, and then you get fired. So anyway, it's a long story. But ref type is the right way to do this. It takes 9 seconds to run the test. PP is just what we usually do, which is just ref equals, which is not really the right way for either use case of it, but okay, so we sort of use that, and that runs at 6. And the XS version, in this case, this is the optimized version with the custom op, runs at 3 seconds. So it's 3 times as fast as the right way of doing this. Now, the interesting thing is that this is without the ref. This is just ref type. You still need to do ref and ref type, so it's even worse. And we're not even getting whether it's blessed or not. Okay, so some common practices. And obviously someone's asking, like, already you got some common practices? Like you just wrote this, which is true. But there are emerging patterns. One interesting thing is that we usually, and someone actually said this to me after I wrote this entire thing, they said, well, what we actually try to find out is whether something is not just a hash ref, but whether it's a non-blessed hash ref, whether it's a plain hash ref. Because the fact that it's blessed, that might be the key component of it, not the part that it's a hash. In fact, if I get a hash ref that is for some reason blessed, I have a problem because I was expecting just a structure that is not blessed, not associated with any namespace. That's what I really care about. So what we do is do this. This basically says, is this a plain hash ref? Because if it's blessed, it will not be this, unless it's blessed into hash. So it's almost, so we need to do this. So we need to say, is it a hash and is it not blessed? Okay? Interestingly enough, you have to do the ref anyway because blessed also returns undef. Okay. Ref util now has is plain hashref instead. I recommend using this more than is hashref. It is much more correct for what you usually really want to ask. Now, blessed hashrefs, blessed hashrefs, array refs, etc., are also confusing because what we need to do is check if it's a ref. If it's a ref, we need to check if it's blessed. If it's blessed, we need to check what the ref type is. And this is actually what we are trying to ask when we check if something is an object of a certain type, right? This is a blessed hashref, but we can check this with a function as well now, okay? And now you can do, is this a blessed hashref? And if so, what is the ref for it? What is the blessed hashref of? All right, Finn, sort of. How much time I have? How much do I have? Sorry. 14 minutes. Great. So here's what I suggest. I have two suggestions. Three. One, I have some extra slides. Two, we have time for questions. Three, we can do both. Who goes for just extra slides? Don't ask us. Don't ask us to ask questions. Okay. Who just wants questions? No extra slides. I cannot take this anymore. Okay. Who wants extra slides and then questions? Okay, great. All right. So I'll do the extra slides. They're not very long. I think they're kind of cool. They're not complicated either. And then we can do questions. So I wrote this thing. First of all, before I finish, I want to thank a bunch of people. I'm not smart enough to write this. Other people are smart enough to write this and to explain it to me. And all of these people have been involved in helping me figure this out, understand it, write it, test it, understand what I wrote, understand why it didn't work, then understand how to fix it and why it then works. And Vikenting is all actually sitting here, right here. And Andreas Gudmundsson, it's hard. Mattia Barbone, Rafael, Eve, Yarko, these people are also core devs in Perl 5 Core, and they're awesome and helpful and amazing. And I want to really thank these people. They are, they've been instrumental in helping me learn and get better, and they still are, because I'm still learning a lot. So thank you very, very much. I really appreciate it. Also, I want to thank this club that we have at work and that allows us to explore the Perl 5 core and to play with it and to write patches for it and to write a bunch of excess awesome modules, and we get like time off work for that, and it's fantastic. And finally, the audience. You guys are awesome. And guys, girls, women, men, anything in between and outside of it. I'm horrible with English, so I apologize for gendered language. So thank you very, 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 very much. Now, no time for applause because one, I don't deserve it, but two, we do have extra slides, so we gotta go to the extra slides. Okay, so bonus slide. I wrote this thing called Ref Util Rewriter. Ref Util Rewriter, basically, you call rewrite string, and then you give it some kind of Perl string. So let's say if ref bar equals code. And then it does, if you give a rewrite file, you can also do that. And what it does then is just rewrite all of it. So let me show you some examples. Ref foo equals array, you have this code, and then it recognizes ref foo, it recognizes array, and then it just does a switcheroo here and says, oh, this is array ref, I got it, no problem. And actually will rewrite the code. So put it in Git first so you can diff and check what it changed. And it will put the foo in there too. It also recognizes it if it has parentheses, okay? And it does it also for a postfix condition. So if it's at the end, it will get that too. Also, if it's unless, it recognizes both. Once it rewrote those, you'll have ones that are inside an if, and then you have a block, and then the postfix, and it will just also recognize it if there is nothing you check it against. You just want to check if it's a ref. So also recognize that, and you get is ref. These are additional situations. This one has an or instead of an if or an unless or an if and then inside it stuff, and it says, hey, no problem, is ref, got it. This one has the or underneath, I got it too. This one has ref equals hash and it gets that as well and rewrites that too. So just put it back there. So it does all of that magic. It's really, really, really nice. The only thing that it can do is that if you drop and you have comments in the same line, it will go, I don't know what this is, I'm sorry. There's a test for it, but I did not implement it. Yes? It should work as well, but could you submit a test? Yes?
You're doing this with PPI.
Oh, how do I do this? He is not a plant. Well, okay, yes. Damn. Todd, you should come with me to every talk that I do. Right, so I use PPI for this. You can find it on github.com, P5P Club, which is our kind of our place for putting stuff that we're playing with, Refutil under tools. Nowadays, there is also, under my GitHub, I'm sorry I didn't update this, under my GitHub, there's also Refutil Rewriter. So you can also do that. Use at your own risk. Thank you again. And this is Refutil with all of the documented stuff, so feel free to go and check it out. This is Refutil Rewriter. I just want to show you how long it is. It's about this long. Sorry, documentation. It's about this long, which is fairly simple. I think it's on Metacpn now. Yeah, Rewriter is not going to give a lot of results. Damn. There we go. So it's actually on CPAN. You can find it. So yeah, that's also kind of cool. The fun thing is that it was very hard for me to understand some of the stuff that I had to write here. So for some things, I actually had to write a very long explanation of what it actually does because I don't even remember or understand fairly well. All right, that's it. Thank you. And now questions. Yes.
Is Refutil going to be in core?
Refutil, I haven't submitted it to core for review at all. People have asked, and I might just poke and see like how horrible is it. Generally, the rule with Perl core is that it has to be good enough that you could do things outside of it. And that is one example. If I could do this without a lot of work outside of it, I could. It was fairly simple. Then there is no reason to integrate it. On the other hand, that might change for some particular tools that are just very, very useful. If this is deemed by people very, very useful with a very low maintenance overhead and a sane implementation, then it is possible. I have not submitted it. If you would like to send an email to the development mailing list saying, I saw this, I asked that question, I received an answer that I don't know, I would like to ask people what they think of it. I would be more than happy to mention that.
I ask is because test 2 has to do the ref and then ref type check all over the place.
Right.
Performance was one of the big things.
Right. Good. Okay. So Chad is working on test 2, by the way. It deserves a lot of credit for that. And one of the considerations for that is how to optimize it. And this would be, at Booking, we actually started using it all over the place because we see a tremendous value and optimization in a lot of core bits. I think that would be a good place for improvement. And what I would need in order to feel like this is really ready for that is to have a PP version, like a pure Perl version, and then an optional XS version, / optional, depending on your version of Perl, custom op version, which is already inside it, it's fine. And then you could say, well, I'm using the pure Perl version, and then if you have that installed, you will also get this super fast version. And if you have an older version of Perl, but you have a compiler, you can install the same thing, but get only a slightly faster version. So I would be more than happy to start working on that. If you would like to contribute, just be careful. You will get a commit bit way too quickly. Yes.
So how do things like develop cover and like T-Prop work with these custom ops? Like, does all that happen far enough ahead that they don't?
So currently there is a ticket that someone submitted. There's a very good question because someone did submit a ticket on the repo basically saying, look, when I try to dump this with a bunch of other stuff, it doesn't work well. So I would like to sort that out. I haven't tried and develop cover and NOA-tprof, but I don't think they manage it well. I need to see. I would not be surprised if they don't handle it well, and I will have to actually refer to a much smarter person to help me with sorting that out. He's actually sitting right next to you. Thank you. Vikenti, I will bug you about that. But that is a very good point. That's something to double check, and if it matters, then possibly not using it. I owe a big thanks to Aaron Crane, also from the Pro 5 porters, who helped tremendously in adding these new and correct functions and accurate functions and cleaning up a lot of the implementation. And to Matthew over there for helping us with with correcting the regex check to be much more compatible and to add that as a compatibility option in develop PP port. Any other question? Yes.
So on your intersub checker function.
Yes. Yes, sir.
You set the ROV sibling, op sibling to null. What was it for?
So I think, Vikinti, could you provide a better explanation than I would for this? So I think the trick was, and I might be wrong on this, okay, you're referring to this line over here,
Yeah.
right? Okay. So if I remember the reason, it was to make sure that the compilation tree just stops there, and then when we return from the call checker, we continue into that sub without executing the rest. I think that is the right one. I might be wrong. I can tell you that if you remove this, it will not work.
Okay.
Do I have another? No. Oh, we have a bit more time. I tend to speak very, very fast. I'm sorry about that. Yes.
Down at the third to last line, you've got is arrayref underscore pp. Should that be off or is it?
Yes, that is horrible naming. Is arrayref is the op implementation of this, and you're absolutely right. That is not a good name for it. It is confusing. I apologize. Todd. Yes.
It's been a while, I've slept since I've messed with that, but I think op sibling null is hinting to, if it may be hinting to B, that when you're walking the tree that there is no sibling you can walk into.
All right, so Todd is saying that the compiler backend actually uses it to determine whether there are any additional siblings to walk into. And that is why it's required. B is the backend part of the compiler for Perl. Does anyone have any other questions? 5, 4, no pressure, 3. All right, well, thank you very, very much for being able to stand all of this. I appreciate the fact that no one fell asleep, no one walked out angry, no one yelled or threw things. Feel free to do that as soon as I leave. Thank you very, very much for your time, and I'll be here if you have any other questions.